Hi class, let's talk about MRSA, methicillin-resistant Staphylococcus aureus. MRSA is a pretty big deal. It's currently on the rise in our country, and it's a very common cause of skin lesions here for individuals that are hospitalized and for non-hospitalized people. Another problem that occurs with Staphylococcus aureus that's methicillin resistant is that it can quickly spread from one person to another person. So these strains of Staphylococcus aureus, though, are going to be resistant to more than just one antibiotic, more than just methicillin. They are going to be resistant to multiple forms of antibiotics. Staphylococcus aureus is the root species behind it. To give you a little bit of the background on that species, the gram-positive coccus, obviously it's a coccus-based species, so it's going to be spherical, and it's going to grow in clusters, hence the term staph. So cluster, staph, coccus, spherical. And it's also capable of growing in highly saline and acidic environments. This bacterium lives on the surface of our skin where we have our sweaty salt drying out. The surface of our skin can go from a basic pH, depending on what we're exposed to, all to an acidic pH. Generally speaking, our skin leans more towards the acidic pH end of the spectrum, and the surface of our skin can also have fairly high temperatures that can be rapidly exposed to. Because the surface of our skin can also dry out, Staphylococcus aureus is going to remain viable after air drying, and it can resist the effects of many disinfectants and antibiotics. God darn it, it's really hard to kill Staphylococcus aureus. This particular strain of Staphylococcus aureus is very virulent, but there are other strains of Staphylococcus aureus that are present on us and that live in a commensalistic relationship with us that don't hurt approximately 1/3 of the U.S. population. Now, if a patient may potentially have not just a staph infection, but a staph infection or a Staphylococcus aureus infection that is antibiotic resistant, there's going to be some raised, red, tender, localized lesions. These lesions often are going to feature some pustules and will feel very hot. There'll be lots of inflammatory response occurring at these lesions. They can occur very easily if there's a break in the skin, so if there's a small nick or tear in the skin. This is one of the big reasons why it's important to degerminate a site of a needle entry before penetrating the skin, or to wash your hands before or after handling a potential contagion, or if you get a little cut. And sometimes, depending on how systemic the infection may be, a fever state could also be induced in the patient. Now, as we look at how this bacterium can be transmitted, you can imagine if it can live in an acidic pH, a basic pH, a neutral pH. It can be in a salty environment, a not salty environment. It can be dried out. It resists many chemicals and can resist antibiotics. God darn it, we can transfer it on pretty much anything. We can transfer it on many different solid objects or fomites that can be used to move it from one patient to another patient. This is one of the reasons this infection is so insidious, because it can be transferred so easily. Individuals that have active MRSA infections should always keep themselves and the infection covered at all times to minimize the amount of transmission that occurs. Here's a nasty picture of a MRSA lesion. Notice how we had large area that's red and heated. There's the raised pustule in the middle, and then within that raised pustule there are smaller areas or pores that are weeping pus or oozing pus, with the main nodule of infection in the center that has some skin breakdown and decomposition occurring. So as we look at MRSA, Staphylococcus aureus, we'll find that the particular strains that cause the issues for us are going to be able to release coagulase, which is one of the enzymes that are associated with pathogenic bacterium. They also are going to produce hydrolyronase, staphylokinase, lipase, and DNase. In other words, these particular strains of bacterium are capable of digesting human flesh. As we culture, or as we're trying to identify or diagnose the particular strain that we're working with, obviously polymerase chain reaction to sequence the DNA is going to be a tried and true technique. Obviously, after running the PCR, we'll need to pair that with gel electrophoresis for final separation of the DNA strands. We can also take the staph bacterium and grow them on a Petri plate, typically a sheep blood agar or a bovine blood agar plate, 5% blood will be used. Or we can use an MSA, mannitol salt agar plate. Catalase is going to distinguish Staphylococcus aureus from other staphylococcal species. So we can take our cultures and expose them to a mild hydrogen peroxide solution. And if it's Staphylococcus aureus, the catalase within the Staphylococcus aureus is going to cause rapid foaming and bubbling, whereas other staphylococcal species won't have that catalase present and won't have the bubbling. And then finally, we can also perform the coagulase test as well. To prevent and treat patients that have Staphylococcus aureus that is antibiotic resistant, we are going to first lean on the prevention end of the spectrum. Good hygiene is the best prevention. There is no there is no vaccine for MRSA, but if we can keep the patients clean and have good hygiene, we can minimize the rate of occurrence and the rate of transmission of this disease. If there is an incision of a lesion, that lesion will typically be incised. This is a MRSA lesion, I should say, or clarify. This lesion needs to be incised, and we need to drain the pus out of the lesion. One of the main reasons for this is because a lesion that is filled with pus is not going to have very good penetration of the antibiotic. There are going to be antibiotic-resistant Staphylococcus aureus bacterium within the pus mixture itself. And since there's very poor circulation within that pussy lesion, any antibiotics that are taken, whether they're oral or intravenous, will have a tough time diffusing all the way into and through the pus of the lesion. So we typically are going to drain out, mechanically clean that lesion. When prescribing antibiotics, because we are working with an antibiotic-resistant bacterium, we are going to give a cocktail of antibiotics that attack multiple structures within the bacterium. So we can work with clindamycin plus TMP or SMZ, or when in doubt, we could just give doxycycline, but that is generally speaking a route that's not favored. We like to go with a combo or a cocktail approach as opposed to using our standalone antibiotics because we want to minimize the amount of new resistances that develop. Here is a result of the coagulase test. This coagulase test can be used to identify streptococcal bacteria. If we look at Streptococcus aureus, it can produce particular strains that are pathogenic, produce coagulase. So we can take some blood plasma and inoculate it with some bacteria. If the blood partially clots or completely clots, notice how the blood is not horizontal with the test tube, even though or with the ground, even though the test tube is tilted. The blood did not tilt horizontally with the ground, but instead remained as a solid mass within the test tube. It's fully coagulated. So these are going to be positive coagulase tests. This bacterium, the staphylococcal species that was inoculated to either of these test tubes, tested positive for coagulase. It coagulated the blood. On the other hand, this result right here shows that the blood serum did not clot when the test tube was tilted. The blood serum was still a liquid and moved around. Ergo, that blood serum was not inoculated with Staphylococcus aureus bacteria that is antibiotic resistant. That's positive for that coagulase enzyme. Here's a summary figure for MRSA. We can see that's methicillin-resistant Staph aureus, Staphylococcus aureus, direct contact and indirect contact. Thankfully, there's still contact. This bacterium cannot be transmitted via the air. There are multiple virulence factors. We can prevent it by being clean. There are multiple cocktails that we can give to treat this antibiotic or this bacterial infection. And many times this infection is going to be very common in children or individuals that touch each other and have poor hygiene, or elderly individuals that also have very poor hygiene. So, concept check class. Why is it so hard to treat a MRSA outbreak, a methicillin-resistant Staphylococcus aureus outbreak? Is it A, because it is antibiotic resistant? B, because it can survive in highly saline environments? C, can resist extreme temperatures and pHs? D, survives being dried out? Or E, all of the above? If you do not know the answer, that is okay. Go ahead and rewind this video, check your PowerPoints, or check your textbook and get me an answer. Go ahead and pause it and get me that answer right now. 1, 2, 3, 4, 5. The correct answer is E, all of the above. It is really, really hard to kill MRSA, and it's so hard to kill MRSA because it resists all of these different things that normally are going to reduce microbial counts. If you have any questions for me about this presentation, please feel free to post them on the class discussion board or shoot me an email. Happy studies!